This video contains audio content only. There are no visual elements or images accompanying the audio. If you're expecting to see video footage, please note that this is an intentional audio-only presentation. We recommend listening to this content rather than watching the screen. Thank you for your understanding and enjoy the audio. Join us as we unravel the captivating story of mongoose evolution. This accessible exploration delves into the mongoose family's remarkable journey, from their ancient origins to their global presence. We'll uncover the secrets of their adaptability, from dietary flexibility and social strategies to their legendary resistance to snake venom and their surprising impact as island invaders. Prepare to be amazed by the power of evolution as we explore the fascinating world of these adaptable hunters. Chapter 1. The Adaptable Hunter. Picture a creature, sleek and agile, weaving effortlessly through dense undergrowth, its sharp eyes alert and searching for prey. This is the mongoose, an extraordinary carnivore whose story spans millions of years, shaped by relentless evolutionary forces. Their tale is one of exceptional adaptability, illustrating evolution's incredible power to craft specialized traits and behaviors across diverse landscapes. To fully appreciate their story, we must first journey back to their origins, tracing the mongoose's fascinating history through the ancient lineage of the family Herpestidae. The mongoose family's origins trace back deep into the Old World, primarily across Africa and Asia. Their earliest ancestors, small, civet-like mammals that roamed these continents tens of millions of years ago, bore little resemblance to today's mongooses. These primitive mammals were generalized creatures, omnivorous and lacking the specialized traits that now define modern mongooses. Yet, over countless generations, environmental pressures sculpted them into predators perfectly attuned to hunting in varied and often challenging landscapes. A significant milestone in mongoose evolution is seen in their dental adaptations. Early ancestors possessed relatively unspecialized teeth, reflecting a more generalist diet. However, over millions of years, mongooses evolved teeth specifically designed for a predatory lifestyle. Their upper fourth premolar and lower first molar, known as the carnassial teeth, became sharp, blade-like tools ideal for shearing flesh and crushing bone. This adaptation allowed mongooses to efficiently exploit a wide variety of prey, from insects and rodents to birds and reptiles. A further dental refinement emerged with the development of an internal cusp on the third upper premolar, enhancing their ability to grip and tear flesh. This progression in dental structure clearly reflects their evolutionary shift toward a predominantly carnivorous lifestyle, driven by the demands of survival and resource availability. One genus, Herpestes, offers a particularly insightful glimpse into mongoose evolution. Fossil records of Herpestes extend back to the Miocene epoch, between 23 and 5 million years ago, uncovering a series of transitional forms. Fossils from Africa and Eurasia show gradual changes, as generalized ancestors slowly gained specialized adaptations. This step-by-step evolutionary progression illustrates how incremental modifications can accumulate to create astonishing biological diversity, giving rise to the various mongoose species we recognize today. The adaptability of mongooses extends far beyond their dentition. They have successfully colonized an impressive range of habitats, from the lush, humid rainforests of Africa and Asia to arid, sparsely vegetated semi-deserts. Such habitat versatility is among their greatest evolutionary achievements. In dense forests, some mongooses have evolved into proficient climbers, skillfully navigating trees with sharp claws and, in certain species, prehensile tails. These arboreal adaptations allow them to access food resources that their ground-bound relatives cannot. Conversely, mongooses living in dry, arid regions have developed remarkable physiological traits for conserving water and withstanding extreme temperatures, enabling them to thrive even where water is scarce. Within the mongoose family, this adaptive versatility is clearly evident. Consider the marsh mongoose, Attylix paludinosus, a semi-aquatic hunter that has developed webbed feet and water-repellent fur. These features are specialized for life along rivers and streams, where it hunts frogs, crabs, and fish. Similarly, the ring-tailed mongoose, Galidia elegans, of Madagascar, another semi-aquatic species, boasts a streamlined body and partially webbed feet, perfectly adapted to pursue aquatic prey. Madagascar's fossa, Cryptoprocta ferox, though also a mongoose, displays even more strikingly unique adaptations. With retractable claws and a sleek, cat-like form, the fossa has evolved an arboreal lifestyle, preying primarily on lemurs in the treetops. This incredible diversity of lifestyles highlights how mongooses have evolved to exploit nearly every conceivable ecological niche. Beyond their physical adaptations, mongooses exhibit impressive dietary flexibility, another key factor in their evolutionary success. Opportunistic feeders, mongooses readily adjust their diets to suit their environment. Species like the slender mongoose, Herpestes sanguineus, prey upon small mammals, birds, and reptiles, while banded mongooses, Mungos mungo, primarily consume insects and invertebrates. Some mongooses even include fruits and seeds in their diet when other food sources are limited. This dietary adaptability allows them to thrive in vastly different habitats, from lush tropical forests to dry savannas. The evolutionary path of mongooses has been significantly shaped by environmental pressures such as competition, predation, and climatic shifts. In regions where multiple mongoose species coexist, competition for resources has driven some to specialize in particular prey types, thereby minimizing direct competition. Predation pressure, particularly from larger carnivores, has favored mongooses with superior agility, speed, and heightened senses. Individuals that could quickly detect and evade predators were more likely to survive and reproduce, passing these advantageous traits on to subsequent generations. Changing climates and shifting vegetation patterns have also exerted significant evolutionary pressures on mongooses. As environments altered, mongooses developed new physiological traits suited to their habitats. In arid environments, for instance, species evolved mechanisms to conserve water, enabling them to endure prolonged droughts. Such adaptations underscore the powerful influence that environmental shifts exert on evolutionary outcomes. Understanding the mongoose's evolutionary origins provides a valuable context for appreciating their diverse social structures and remarkable adaptations, which will be explored in subsequent chapters. Their social behaviors range widely, from solitary hunters to cooperative societies with intricate communication systems. Their unique ability to resist snake venom exemplifies evolutionary arms races, a fascinating subject we will delve into later. We will also trace their incredible spread across islands, revealing how introduced populations adapt rapidly to new ecological conditions. The mongoose, ever resourceful and adaptable, still holds many secrets to unveil. Chapter 2. Complex social lives. Imagine a mongoose quietly stalking its prey, a solitary hunter, sleek and elusive. Yet, this solitary image captures only a fraction of mongoose social behavior. Their social structures are incredibly diverse, ranging from solitary existence to devoted pairs and complex, cooperative communities. This social diversity demonstrates yet another facet of the mongoose's remarkable adaptability. Many mongoose species, including the slender mongoose of Africa, spend their lives largely alone, fiercely protecting their individual territories. Although solitary living may seem isolating, it offers significant advantages in environments where food is scattered or limited. A lone hunter keeps every hard-won meal to itself and can remain stealthy, reducing the risk of attracting predators. Other species, such as the Cape gray mongoose and the white-tailed mongoose, occasionally forage in pairs but typically maintain separate territories and den alone or with immediate family. For these species, solitary hunting represents a practical adaptation, effectively balancing the need for food with safety from predators. However, solitude is not the only successful strategy. In Madagascar, the ring-tailed mongoose demonstrates an alternative adaptation: strong pair bonds. In this lifestyle, mates share territory, dens, and parental duties. Cooperation between the pair enhances their ability to raise young and defend resources. This system of shared responsibility allows the pair to capitalize on the benefits of individual hunting, while collectively securing their territory and offspring against threats. The most compelling social adaptations among mongooses are exhibited by species that live in groups. Group living provides numerous advantages, particularly for smaller species like the yellow and dwarf mongooses, which face significant predation threats. Collective vigilance, with multiple individuals watching for predators, greatly enhances survival. In addition, their diets, dominated by abundant insects and other invertebrates, reduce direct competition for food, making group living advantageous. Group-living mongooses form societies governed by strict hierarchies, often dominated by a single breeding pair. Unlike other mammals, dominance among mongooses is not solely dictated by physical strength. Instead, age, experience, personality, and assertiveness determine social rank. Intriguingly, females frequently occupy dominant positions, shaping group dynamics with assertive behaviors rather than brute force. Social group sizes among mongooses vary considerably, from small family units of 3 to 8, as seen in the Liberian mongoose, to the impressively large bands of the banded mongoose, which can swell to over 40 members. Life within these larger groups is highly coordinated and marked by constant activity, including communal foraging, territorial patrols, and joint defense against predators or rival groups. The banded mongoose offers particularly captivating insights into cooperative breeding, displaying a fascinating evolutionary adaptation: synchronized births. Remarkably, females within a banded mongoose group give birth simultaneously, usually within a single night. This synchronized reproduction is not accidental. Females who might otherwise deliver slightly earlier or later adjust their reproductive cycles to align with the group. This synchronized birthing strategy, though seemingly severe, pups born outside this narrow time frame are frequently killed by dominant females, is vital for maintaining social cohesion and ensuring equal care for all offspring. Pup rearing among banded mongooses is a communal affair. Females nurse pups collectively, ensuring all young receive sufficient nourishment regardless of their parentage. As pups mature, they are accompanied and protected by adult escorts, which guide them on foraging expeditions. These escorts, often unrelated to the pups they care for, provide protection and education, teaching young mongooses essential survival skills. This cooperative breeding approach not only ensures the survival of offspring but strengthens group bonds, contributing significantly to the long-term success of the group. Yet, mongoose social life is not devoid of conflict. Territorial disputes between neighboring mongoose groups can erupt into violent encounters, vividly illustrating the complex interplay of cooperation and competition within mongoose communities. These battles, described as mongoose wars, are reminiscent of human conflicts, driven by territorial boundaries, resource scarcity, and strategic power struggles. Picture two rival mongoose groups encountering each other along a disputed boundary. Members form opposing lines, confronting each other with aggressive vocalizations and intimidating displays. Tension escalates until, suddenly, the two sides charge, engaging in fierce, chaotic battles filled with biting, scratching, and vocal aggression. These confrontations, sometimes lasting over an hour, can have severe outcomes, including injury or death. Interestingly, these battles often involve behaviors that appear counterintuitive from an evolutionary perspective. During conflicts, dominant females sometimes mate with males from opposing groups, a risky yet strategic move that introduces genetic diversity into their own communities. Meanwhile, males frequently target and kill pups from rival groups, a brutal tactic aimed at weakening competitors by eliminating the next generation of potential rivals. This strategy, though harsh, clearly illustrates the complex interplay of evolutionary pressures shaping mongoose societies. Communication is critical in the mongoose world, linking individuals whether solitary or socially grouped. Scent marking, using secretions from anal glands and, in some species, cheek and chest glands, allows mongooses to broadcast essential information to others. These chemical signals communicate individual identity, reproductive status, and social rank, playing a vital role in territorial marking and mate attraction. Territorial boundaries are clearly marked, and dominance hierarchies are reinforced through these invisible yet powerful messages. Vocal communication is equally important, especially among social mongooses. Their vocal repertoire includes chirps, whistles, growls, and screams, each sound carrying precise meaning. Alarm calls signal danger, coordinating group movements or alerting others to threats. Contact calls maintain cohesion within groups as they forage through dense vegetation or navigate challenging terrain. Dwarf mongooses, for instance, use constant vocal communication to remain connected in the field, enhancing their collective vigilance and effectiveness. Interestingly, mongoose pups in group-living species have evolved behaviors that conceal their individual identities, particularly through scent. By lacking a distinct scent profile, pups effectively blend in, reducing their vulnerability to aggression from unrelated adults. This strategy helps pups avoid favoritism or targeted aggression, encouraging more equitable care and support from group members. This adaptation highlights the complex balance mongooses maintain between cooperation and competition within their societies. The social structures of mongooses, from solitary lifestyles to complex group societies, are shaped significantly by ecological pressures. The availability of food, the threat of predators, and competition for resources are powerful evolutionary forces that have driven the development of these varied strategies. Solitary mongooses, like the slender mongoose, thrive precisely because solitary foraging optimizes their use of scarce resources. Pair-living species balance resource sharing and cooperative breeding, reaping the benefits of both independence and cooperation. Group-living species, such as the banded mongoose, represent a pinnacle of social adaptation, harnessing collective effort to overcome environmental challenges. The varied and sophisticated social structures of mongooses are a testament to their remarkable evolutionary flexibility. Their ability to adapt socially, just as effectively as they do physically, ensures their survival and success across a staggering array of environments. From solitary hunters quietly stalking prey to the vibrant and dynamic communities that defend territories, raise offspring cooperatively, and engage in fierce battles, mongooses continue to reveal the extraordinary depth of their evolutionary adaptations. Understanding these social adaptations provides valuable insights into the evolutionary mechanisms shaping animal behavior more broadly. Whether facing the challenges of solitary life or thriving in bustling, cooperative groups, mongooses have proven to be some of the animal kingdom's most adept survivors. Their social complexity, built through millions of years of evolutionary pressures, remains a compelling illustration of nature's boundless ingenuity and adaptability. Chapter 3. An Evolutionary Arms Race: The Mongoose and the Venomous Snake. Picture an open clearing, where a mongoose and a venomous snake face each other in an intense standoff. Their duel, one of nature's most captivating spectacles, represents far more than a simple confrontation between predator and prey. It is an intricate dance shaped by millions of years of evolutionary adaptation. The relationship between mongooses and venomous snakes is a classic example of an evolutionary arms race, a continual push and pull in which each side refines its defenses and strategies in response to the other. Central to the mongoose's extraordinary success against venomous snakes are remarkable genetic adaptations that grant resistance, though not immunity, to snake venom. At the molecular level, the mongoose has evolved modifications to the acetylcholine receptors, crucial proteins in nerve cells that snake neurotoxins typically target. Normally, snake venom binds to these receptors, causing paralysis and rapid death. However, mongooses possess genetic mutations altering the receptor structure, effectively blocking the venom's deadly effects. Imagine changing the lock on a door so that the snake's venomous key no longer fits. These receptor modifications are critical adaptations, honed by selective pressures imposed by venomous snakes. Not all mongooses share the same degree of venom resistance. This resistance varies widely depending on each species' specific ecological environment and the venomous snakes they encounter. The Indian gray mongoose, Urva edwards E., renowned for its confrontations with the king cobra, boasts particularly high resistance to neurotoxins, clearly reflecting the intense evolutionary pressure from this powerful predator. In contrast, mongoose species living in areas with less venomous snakes possess lower levels of resistance, highlighting the adaptive flexibility of this evolutionary defense. Beyond receptor adaptations, mongooses also have another powerful defensive tool: a specialized glycoprotein capable of actively neutralizing venom. This glycoprotein binds venom molecules, rendering them harmless. This added layer of biochemical defense offers protection even against venoms that might bypass modified receptors. Yet, despite these formidable adaptations, mongooses are not invincible. Massive doses of venom or repeated bites can overwhelm even their impressive defenses. Thus, mongooses employ a combination of genetic, physical, and behavioral strategies to minimize the danger posed by venomous snakes. Their physical defenses start with their dense fur, which offers a critical initial barrier against snake fangs. Thick, coarse hairs can deflect or absorb the impact of strikes, reducing the quantity of venom delivered. But the mongoose's greatest advantage lies in its remarkable agility and strategic hunting tactics. Rather than relying solely on biochemical defenses, mongooses have become skilled snake hunters through precise, coordinated movements and quick reflexes. A mongoose attacking a snake employs a careful strategy, never recklessly charging its adversary. Instead, it executes a series of rapid, darting movements, feints, and lunges to provoke the snake into striking prematurely. By doing so, the mongoose creates openings for a swift, decisive bite, typically aiming directly at the snake's head. Its goal is clear: neutralize the snake quickly, avoiding dangerous, venomous bites. Moreover, their thick fur provides a crucial layer of defense, shielding them from direct puncture wounds. A mongoose's dense fur, especially around the neck and torso, can deflect snake strikes, significantly reducing the chance that venom reaches the bloodstream. Combined with agility and speed, this fur acts as a natural armor, giving the mongoose a substantial advantage in these deadly encounters. While stories of mongooses battling snakes date back centuries, scientific studies have documented a variety of hunting tactics employed across mongoose species. Some mongooses utilize unique methods, like flicking their tails as a distracting lure, drawing the snake's attention away from vulnerable body parts. Others strategically target the snake's head, striking swiftly to incapacitate the reptile before it can effectively retaliate. Such tactics highlight their behavioral intelligence, showcasing a finely honed balance between instinct and learned behavior. Indeed, the mongoose's skills in confronting venomous snakes are shaped by both innate instincts and learned experiences. Research on banded mongooses and dwarf mongooses reveals that young individuals often learn effective snake hunting strategies by observing adults. Adult mongooses regularly mentor younger group members, demonstrating techniques and gradually allowing pups to practice and refine their hunting skills. This social learning component reinforces their genetic predispositions, illustrating how mongoose society itself contributes to their evolutionary success against venomous adversaries. Yet, the evolutionary arms race between mongooses and venomous snakes is not one-sided. Snakes have adapted too, developing counter-strategies in response to mongoose predation. In regions with high mongoose populations, venomous snakes have evolved larger venom glands or more potent venom, increasing the likelihood of delivering a lethal dose in the limited opportunities they have to strike. Some snake species have also adapted their attack behaviors, aiming for less protected body areas, circumventing the mongoose's dense fur armor. This mutual evolutionary pressure drives continuous adaptation in both predator and prey, shaping their biology, behavior, and survival strategies. This evolutionary arms race represents a classic example of coevolution, an ongoing, dynamic interaction where each adaptation by one species prompts a counter-adaptation in the other. Mongooses become more resistant, snakes become more venomous, and each advance leads to a reciprocal adaptation in this remarkable biological chess match. Such co-evolutionary dynamics are vivid examples of natural selection, continually shaping the mongoose's resistance and hunting techniques, as well as the snake's defensive and offensive strategies. The mongoose-snake conflict is also an illustration of evolutionary trade-offs. Resistance to snake venom comes with biological costs, as the modified acetylcholine receptors in mongooses might reduce nerve transmission efficiency, potentially impacting other aspects of nervous system function. Thus, mongooses must strike a careful evolutionary balance between resistance and overall physiological performance. Their adaptations reflect a finely tuned compromise, demonstrating that evolution seldom produces perfect solutions, only solutions good enough to survive. One notable example frequently referenced is the famous encounter described by naturalists observing an Indian gray mongoose battling a king cobra in 1944. Beyond this anecdote, recent field observations provide detailed insight into varied hunting strategies. In Africa, banded mongooses have been documented flicking their tails as distractions, luring snakes into strikes aimed at non-vital body parts. Others dig to uncover hiding snakes, forcing their adversaries into exposed positions where they're more vulnerable. This behavioral versatility underscores the mongoose's incredible adaptability when confronting venomous snakes. Despite their formidable adaptations, mongooses exercise caution in choosing their prey. They often avoid snakes too large or dangerous, unless forced by hunger or territorial defense. Their success is carefully calculated, as reckless hunting could swiftly end in death. This behavioral flexibility, combined with their physical and genetic defenses, solidifies their position as one of the natural world's most accomplished predators. Ultimately, the mongoose-snake relationship exemplifies evolution as a never-ending arms race, a constant push and pull dynamic in which no side achieves permanent victory. Instead, each species evolves in response to the strengths and weaknesses of the other, driving mutual evolutionary change. Far from being simply immune to venom, mongooses possess a sophisticated defense system developed through millions of years of relentless evolutionary pressure. The story of the mongoose and the venomous snake encapsulates evolution's essence, an unending competition for survival, an arms race defined by adaptation and counter-adaptation. The mongoose, with its agility, intelligence, and biochemical weaponry, stands as one of nature's most compelling examples of how organisms evolve specialized traits to overcome deadly challenges. Their ongoing battle with venomous snakes reminds us of evolution's constant drive, forever sculpting new forms and behaviors in the endless quest for survival. This remarkable chapter in mongoose evolution sets the stage for an even broader understanding of their global story. In the next chapters, we will explore how their adaptability allowed mongooses to thrive even in entirely new environments, including islands around the world, often with profound consequences for ecosystems that had never before encountered such versatile predators. Chapter 4. Island Invaders. Imagine a small, agile predator arriving on an island where it never existed before, a place where native species evolved without fear of such a formidable hunter. This is the story of the mongoose as an island invader, a role in which its remarkable adaptability is both its greatest strength and the source of profound ecological disruption. Over the past 2 centuries, mongooses, particularly the small Indian mongoose, Urva oripunctatus, have been deliberately introduced to over 60 islands around the world, usually with well-intentioned motives that later spiraled into ecological crises. In the late 19th century, plantation owners desperate to control rodents damaging sugarcane crops began introducing mongooses to islands across the Caribbean, Pacific, and beyond. The logic seemed clear. Mongooses were skilled rodent hunters, and their introduction promised a natural solution to agricultural pests. However, the consequences of these introductions quickly shifted from beneficial to catastrophic. Instead of targeting only rats, mongooses rapidly adapted to island life, expanding their diets and reproducing swiftly, ultimately devastating native wildlife that had never faced such efficient predators. The small Indian mongoose, Urva oripunctatus, introduced to islands such as Hawaii in 1883, Fiji in 1883, and multiple Caribbean islands between 1870 and 1872, rapidly established thriving populations. Their adaptability, high reproductive rates, and opportunistic diet transformed these intended biological control agents into severe threats to native biodiversity. On islands with no prior terrestrial predators, local wildlife was uniquely vulnerable, and mongooses exploited this vulnerability with alarming efficiency. A striking example of mongoose-driven ecological collapse occurred in Hawaii. Ground-nesting birds like the Hawaiian petrel, Pterodroma sandwichensis, suffered devastating losses, with populations plummeting as mongooses targeted nests and fledglings. On Fiji, native reptiles and amphibians, including the once common Fijian ground frog, Platymantis viciana, declined dramatically due to mongoose predation. Similarly, islands in the West Indies experienced rapid declines in reptiles, birds, and amphibians, with some species teetering on extinction. The Jamaican iguana, Cyclura caule, for instance, was pushed to near extinction largely due to mongoose predation. Across these islands, native species evolved with no defenses against such agile predators, leaving them profoundly vulnerable and unable to adapt quickly enough to withstand the mongoose invasion. But the mongoose's invasion had more than just direct impacts on prey species. Their presence disrupted ecological relationships in subtle yet far-reaching ways. By preying heavily on native birds and reptiles, mongooses indirectly altered island ecosystems, reducing seed dispersal, competing with native insectivores, and fundamentally changing the ecological balance. This cascading effect was most evident on islands with delicate ecosystems, where even small disruptions caused significant environmental consequences. Remarkably, island environments also spurred rapid evolutionary changes in mongooses themselves. The small Indian mongoose introduced to these islands displayed significant physical and behavioral adaptations in relatively short periods, evidence of evolution in action. One notable adaptation involves a curious change in male mongooses' scent-marking behavior. On many islands, male mongooses developed significantly smaller anal scent glands, used in their native range for sexual signaling. Researchers believe this reduction is due to relaxed sexual selection pressures in island environments. With increased population densities on islands, mongooses encounter potential mates more frequently, reducing the need for extensive scent marking to attract females. Interestingly, this adaptation coincided with an increase in testis size among island mongoose populations, likely due to intensified sperm competition resulting from more frequent mating opportunities. Such physiological shifts demonstrate how rapidly environmental pressures can influence evolutionary trajectories, even within a few generations. This rapid morphological change provides clear evidence of evolution in action, highlighting how quickly mongooses respond genetically to new ecological pressures. Beyond sexual traits, morphological changes resulting from competitive interactions have also emerged among island populations. In the Adriatic Islands, mongooses coexist with another carnivore, the native stone marten, Martes foina. Here, mongooses exhibit noticeably smaller skulls and reduced canine teeth compared to populations on nearby islands where martens are absent. This change, known as character displacement, suggests mongooses have adapted to reduce dietary overlap and competition, shifting toward smaller prey types or different food sources to avoid direct resource competition. The marten, in turn, shows morphological shifts in response, demonstrating reciprocal evolutionary pressures driven by competition. Behaviorally, island mongooses have also adapted in significant ways. On several islands, mongooses shifted their diet to consume readily available prey, such as introduced rodents or abundant invertebrates. Changes in their activity patterns, such as increased nocturnality, have also been documented, likely in response to competition or predation pressures. These adaptations further highlight the incredible plasticity of mongooses, enabling them to swiftly adjust their lifestyles and behaviors to thrive in entirely new ecological contexts. Yet, despite these adaptations, mongoose populations remain challenging to control or eradicate once established. Attempts at eradication or control have achieved varying degrees of success, depending largely on island size, topography, and the complexity of mongoose populations. On smaller islands, intensive trapping combined with community participation has sometimes resulted in successful eradication, as seen on certain Caribbean islands. However, on larger islands like Hawaii, eradication has proven elusive due to mongooses' resilience, reproductive capabilities, and ability to thrive even in remote habitats. The difficulty of controlling mongoose populations underscores an important lesson about invasive species management. Even species introduced with good intentions, like mongooses to control agricultural pests, can lead to severe, unintended ecological consequences. These outcomes demonstrate the profound risks involved in introducing predators to ecosystems unprepared for their arrival. The story of mongoose introductions thus serves as a powerful cautionary tale, emphasizing the importance of careful ecological assessment before introducing species into new environments. Despite the environmental harm they cause, island mongoose populations offer unique insights into evolutionary processes. Their rapid adaptations underscore evolution's ability to respond swiftly to new ecological conditions. The character displacement observed in the Adriatic, the reduced scent-marking organs, and shifts in reproductive traits are vivid examples of how quickly evolution can shape morphology and behavior when organisms face novel ecological challenges. In the broader evolutionary narrative, the mongoose's island invasions reveal evolution as a dynamic and rapid force, not limited to ancient, gradual changes, but actively reshaping organisms within mere generations. Island mongooses stand as living laboratories, demonstrating how quickly and profoundly evolution can act when species confront new environmental pressures. In tracing the mongoose's journey from intentionally introduced predator to ecological threat, we see a microcosm of evolution's complexity and unpredictability. The mongoose, so adept at adapting to varied environments, becomes a victim of its success. Its versatility, an evolutionary advantage in its native habitats, turns destructive when released into ecosystems that have never encountered such adaptable predators. The introduction of mongooses worldwide illustrates how evolutionary success, unchecked by natural ecological constraints, can lead to unintended devastation. Thus, the mongoose story reveals not only the creature's extraordinary adaptability but also the profound responsibility humans bear when introducing animals into new ecosystems. The mongoose's island invasions teach us about the fragile balance within ecosystems, and how quickly and irreversibly this balance can shift. These cautionary tales remind us that, while adaptability is a marvel of nature, it can carry severe consequences when unleashed without restraint. As we move forward, we'll see that the mongoose's story, both inspiring and cautionary, continues to unfold, illuminating the complex relationship between evolution, environment, and human intervention. Their extraordinary ability to survive and thrive underlines evolution's power to shape life in unpredictable and sometimes alarming ways, setting the stage for the final reflections on their global journey and ecological legacy. Chapter 5. A Chronicle of the Mongoose. From humble origins to global conquerors. The mongoose story, spanning continents, islands, and epochs, is a chronicle of resilience, ingenuity, and adaptation. From their humble origins as small, generalized mammals to their emergence as highly specialized, adaptable carnivores, mongooses have persistently navigated the complexities of ecological challenges, competition, and changing landscapes. Their journey, one of relentless evolution and global conquest, offers a profound glimpse into nature's extraordinary creativity and adaptability. To truly appreciate the mongoose's success, we return briefly to their ancient roots. The mongoose family, Herpestidae, first emerged during the Miocene epoch between 23 and 5 million years ago. Fossil records from this period uncover early ancestors possessing generalized physical traits and omnivorous diets, distinctly different from modern mongooses. Over millions of years, however, environmental pressures shaped their bodies and behaviors, forging highly specialized traits perfectly attuned to their predatory lifestyles. This gradual transition from generalists to specialists is vividly represented in their dental evolution. Early mongoose ancestors possessed relatively unspecialized dentition, suitable for a varied diet. Yet, as they adapted increasingly toward carnivory, their teeth transformed accordingly. Carnassial teeth developed into precise shearing blades, optimized for cutting through flesh and crushing bones, and specialized cusp structures emerged, enhancing their grip and tearing ability. These dental modifications illustrate how dietary specialization, driven by environmental demands, profoundly influenced mongoose evolution. Beyond dentition, their ability to thrive across diverse habitats highlights their evolutionary adaptability. From the humid rainforests of Africa and Asia to arid semi-deserts, mongooses conquered vastly different landscapes by evolving specialized physical traits and behaviors. Rainforest-dwelling species evolved arboreal adaptations, such as sharp claws and agile climbing skills, to exploit forest resources unavailable to ground-based relatives. In arid environments, mongooses developed remarkable physiological mechanisms to conserve water, enabling them to survive in habitats where other carnivores could not. These varied adaptations underscore their evolutionary flexibility, allowing mongooses to inhabit and thrive in remarkably distinct ecological niches. Their adaptability extends not only to habitats but also to their social structures. Mongooses exhibit astonishing variability in social behaviors, reflecting deep evolutionary responses to ecological pressures. Solitary mongooses, like Africa's slender mongoose, evolved territorial lifestyles suited to environments where food resources are dispersed, promoting individual rather than communal hunting. Pair-bonded mongooses, such as Madagascar's ring-tailed mongoose, adopted cooperation between mates, jointly raising offspring and defending territories. Meanwhile, group-living species such as the banded mongoose took social complexity further, developing sophisticated cooperative behaviors, hierarchical structures, and collective defense strategies to cope with predation pressure and resource availability. In highly social mongoose species, evolutionary pressures produced remarkable behaviors. The synchronized births among banded mongooses, where females coordinate the timing of their offspring's arrival, represent an extraordinary adaptation to communal living. Such synchronization, though severe in outcome, pups born outside the narrow birth window often face infanticide, ensures equitable parental care and strengthens group cohesion. Additionally, communal pup care and teaching behaviors, where older mongooses guide and protect younger individuals, underscore evolutionary advantages of cooperative breeding. Social mongooses also developed complex communication systems involving vocalizations and chemical signaling, reflecting another facet of their evolutionary adaptability. Chemical communication through scent marking delineates territories, signals reproductive status, and conveys dominance hierarchies, essential for managing intricate social relationships. Vocal communication, including alarms, contact calls, and aggressive signals, allows group coordination, enhancing survival prospects in habitats fraught with danger and competition. One of the mongoose's most celebrated adaptations, their ability to combat venomous snakes, further highlights their evolutionary sophistication. Rather than simple immunity, mongooses evolved a combination of molecular, physical, and behavioral defenses honed by an intense evolutionary arms race with snakes. Genetic adaptations, such as modified acetylcholine receptors that resist neurotoxin binding, provide a biochemical defense against venom. Additionally, specialized glycoproteins neutralize venom molecules, reinforcing biochemical defenses. These molecular adaptations, however, do not confer absolute immunity, necessitating careful hunting tactics, dense protective fur, swift agility, and strategic targeting of snakeheads during attacks. This ongoing evolutionary arms race is reciprocal. Venomous snakes have evolved counter-adaptations, such as more potent venom and refined striking behaviors, aimed at exploiting mongoose vulnerabilities. The result is a dynamic co-evolutionary relationship, continuously driving further adaptation and illustrating the endless push and pull of natural selection. The mongoose's adaptability became strikingly apparent through their colonization of islands worldwide, a largely human-driven phenomenon with profound ecological consequences. The small Indian mongoose, Urva oripunctatus, intentionally introduced to numerous islands during the late 19th century to control agricultural pests, rapidly became invasive. Unchecked by natural predators, mongooses thrived, rapidly adapting to island life. Unfortunately, native island species, never previously exposed to such predators, suffered catastrophic declines, as mongooses decimated populations of ground-nesting birds, reptiles, and amphibians. The mongoose's impact extended beyond direct predation, altering ecological relationships and processes. By reducing seed dispersal and competing with native insectivores, mongooses disrupted intricate ecological webs, causing cascading environmental changes. These unintended outcomes serve as powerful cautionary tales about the risks inherent in introducing non-native species, even those introduced with beneficial intentions. Yet these island invasions also revealed evolutionary adaptations occurring rapidly within mongoose populations themselves. Morphological changes emerged swiftly, including reduced scent glands among island males, a result of relaxed sexual selection, and altered skull sizes due to competition with native predators, exemplified by Adriatic island mongooses. Behavioral shifts, such as altered diets and changes in activity patterns, occurred within just a few generations, vividly demonstrating evolution's rapid response to novel ecological pressures. Managing invasive mongooses remains challenging, particularly on larger islands, highlighting the ecological complexities and practical difficulties inherent in reversing human-driven introductions. These experiences underscore the profound responsibility associated with human interventions in ecosystems, and the lasting ecological footprints invasive species can leave behind. The mongoose story is thus a powerful narrative, weaving together threads of evolutionary adaptation, human intervention, and ecological consequences. Their journey, from ancient ancestors navigating prehistoric landscapes to adaptable global conquerors influencing ecosystems worldwide, encapsulates both the marvels and pitfalls of evolutionary adaptability. Mongooses demonstrate evolution's boundless creativity and its capacity for rapid change, reflecting life's endless responsiveness to ecological challenges. However, the mongoose saga also carries a sobering lesson about unintended consequences. Their impressive adaptability, once beneficial in natural habitats, became destructive when freed from ecological checks and balances. These invasions underscore the delicate balance ecosystems require and the unforeseen dangers inherent in disturbing this balance, even with good intentions. As we reflect upon the mongoose's evolutionary journey, we confront essential questions about our relationship with nature. While their story highlights evolution's power, adaptability, and resilience, it equally emphasizes human accountability in shaping ecological outcomes. Understanding this balance provides critical insights for conservation efforts, invasive species management, and ecological stewardship. In the end, the Mongoose Chronicle stands as both a testament to evolution's remarkable capabilities and a cautionary tale reminding us of our ecological responsibilities. Their success, versatility, and global presence are testaments to evolution's ingenuity, while the consequences of their introduction illustrate vividly the careful stewardship required when intervening in nature. Ultimately, the mongoose story compels us toward a deeper respect for ecological complexity, caution in managing ecosystems, and admiration for evolution's enduring creativity. Mongooses, originating in Africa and Asia, showcase remarkable evolutionary adaptations, from specialized teeth for carnivory to diverse social structures ranging from solitary living to complex cooperative groups. Their famed resistance to snake venom stems from modified acetylcholine receptors and venom-neutralizing glycoproteins, coupled with agile hunting strategies. Introduced to islands worldwide, mongooses have adapted rapidly, demonstrating character displacement and altered sexual selection pressures, though often with detrimental impacts on native species. These evolutionary tales reveal the dynamic interplay between organisms and their environments. What other remarkable adaptations might we uncover as research continues? Share your thoughts and questions below. Like, subscribe, and suggest future topics. Let's keep exploring the wonders of the natural world together.